What is up? Almost forgot to even make a video. So I got this mill here, CNC 3D 18 Pro. It's off of Amazon for like 200 bucks. And for light duty, you know, what I'm going to use it for to etch some, or mill, you know, some circuit boards. You know, I've also bought some cheap boards for when I put it together to carve. The idea is to make some circuit boards without having to have them made. And you know, I've been like making my last couple circuits out of a breadboard like this, and it turns into a hell of a mess, even though it does work. Some of them have worked really well. I've had circuit boards made before, and I've showed these before. Like here's one of the ones I had, and of course I had to modify it afterwards a little bit, but something like this, you know, I had to make for myself. But this one here actually had you know, used one of the CAD software, then you paid a couple bucks and they mail you these boards. So instead of, I was about to do that again to make a couple of those. You get like 3 boards for like 60 bucks. I think it's more like 69 bucks now, plus the shipping and everything. It's gonna be close to 100 bucks, I think, by the time I was gonna get like 3 boards made. And if there was any mistakes, I'd just be stuck with them. Well, for 200 bucks, you just, you know, get one of these mill things right here, and using some software and stuff, which I started messing around with it while I was waiting for it to arrive. Here's my circuit board that I showed earlier. This is just the top layer. Let's see, Frankenstein heat pump control 2022. Yes. So hopefully everything works when I get it all hooked up. I got that far, but that's the idea. I've actually taken like an imprint of something like this before, printed it out on a laser toner printer, like that one down there. It's collecting dust. Get it to just print as dark as you can, and then you actually kind of lay the piece of paper, you know, with the toner side down on your copper clad here, and then take like a freaking hot clothing iron and you like push it on there really hard and hot, and just push it real hard for a couple minutes and then let it cool off. And it actually will transfer the toner to this. And then you could put this into the etching solution. You know, it's good to agitate it or, you know, spray the solution around. But it's pretty temperamental because you don't do it long enough, it doesn't eat enough copper away. But if you get to the point where it actually eats all the copper away that you need to be eaten away, sometimes it starts eating through the toner, you know, and then it's really hard. Temperamental kind of works, but not good enough. So anyway, one thing I'm doing right now is what made me think of making just a video clip was that it doesn't say anything about, you know, precision, but I kind of imagine that this part that slides back and forth should probably be kind of precise. Although I guess, yeah, because if you square your part up on it, you know, you're going, if you're going to go off of this base, this platform, you know, you need it to be squared. So here's a little thing I did was I just took this, my speed square here, and just kind of put it to this here and just kind of got it squared up there. And it looks like I should be good. And I'm tightening up all the fasteners and whatnot. It doesn't say anything about torque either, so I don't know. I'll just probably make something up like 25 inch-pounds or something and just go for it. Anyway, we'll see how this goes. Well, I got impatient for a piece of test, so I just took a piece of cardboard on there, which is, you know, not so thick, so hopefully it doesn't drive it into the freaking base plate. But I think for the little test program they gave me, it just barely has any depth at all. It's just drawing the word iPhone. This is the test one. Actually seems to be kind of doing it. Of course, cardboard is going to shred, but I got all the wires all hooked up. I added these 3M little stickers on here to fasten all these cables and stuff, so it seems to be working. Okay, let's put a piece of sacrificial wood I had, some floorboard. These are the brackets that this thing comes with. and I think this is the way they had them. I've seen some videos. People complained about them, so I know I'm going to have to make something better. And actually, this right here is very secure, so I'll probably keep this piece of wood and maybe put some recessed holes in the bottom and some other jigs up to make it hold my circuit boards and make it be my circuit board. So, being the first time, I'll have to learn from error and whatnot. And I can see already that kind of routers around the traces. So this long line here is actually routed around a trace, and it left that trace super thin. I mean, look, you can barely see like a hairline. And I just carefully took my continuity meter and checked that, and it actually has continuity. It left a hairline, but yeah. So probably went just a pinch too deep. I got a setting wrong. I don't know. I was following some videos. You calculate, you look up the bit size, and then you calculate it. It's like a 0.1 with a 20 degree or something like that. You put it in, it comes out to like a 1 point something. And I put that in. So the other live and you learn thing will be the width of the traces, which I think I increased it from what the original default setting was. But I can see that it's too small. Plus it won't be as forgiving as if I don't get the depth set or the bit set program perfect or whatever. I went ahead and aborted that deal. Some of it would have been okay, but those traces way too skinny. Also, it's going to make a bunch of these via points. I guess that's what they called. Look how close it is. And what it is when I moved my components and kept making it auto route again, because it was so close together, because it was nice the way it was at first actually, it makes these via points where, so it comes out top layer, jumps to the bottom layer, you know. It has one there, it's in a bad spot, it has one there. That one's not so bad, but a couple of them were real close to some other points that I didn't like. There's one right here next to that. I think that's what I'm looking at. Around here. Yep, push button, push button, push button. There's a via point. Right here, it just sucks. Goes right around that. What do you want to call that? Where just, you got to drill a hole, and it didn't make a real big spot to drill holes. I mean, it would work if I had it professionally made. On professional machines, but not doing it with that. So I think what I'm going to do is I'm just going to go ahead and get to my circuit, can change it up a little bit. And I think what I might do, just to make it real simple, is take all these components right here. This is my AC 24 volts, goes to the optical isolators. I think I'll just make a small little, I'll put these all on their own board. Probably can make that whole layout pretty straightforward. Put it like on, probably put 2 of them on here, you know, maybe even do it one layer, probably. Well, good news and bad news. After realizing how to do the height mapping, which it's doing right now on another board, I threw in some settings and actually etched that board, which looks like it came out great. Bad news was I was just doing testing and I already kind of screwed up the board right here, and so it just, you know, did its work right on top of that. So I would have been able to cut this out and use it, but it's got this mark going right there. I could actually still cut it out and just jumper across that, but anyway, I'm going to go ahead and try doing it again. I just made this design even smaller, so I'm going to try to fit it on half this board. This is a board I already cut a hole in over here and did some stuff on the other side. So I'm going to do a single-sided one. Basically, it's going to be a 24-volt interface board. Should be about this big. Actually, a little smaller once this gets done. And so it'll be 24 volts, thermostat inputs, basically, optical isolators, and then it's going to switch 5 volts out, which is going to go, you know, be the logical level inputs. So pretty much just makes this 3D map of the varying, you know, heights of your piece of copper, and adjusts the CNC work to the actual level. If you looked across that copper plane, and these are cheap, you know, copper ones, you're only talking, you know, fraction of a millimeter, but still, it gives you the option to save it. I'm going to hit make this be the height map 2. There it is. You have to click this edit button, and then it gets me back to showing this, and now it's showing all the probed, the elevations have been all adjusted. So now, take this cable off. Kind of sucks when you forget to do that. Usually put it way down right on the probe, but that time I can put it. So I should be able to ready to turn on the spindle. And then you're going to hit send. That looks like I put my logo on first, which is Frankenstein 24-volt interface. Right at the bottom left. Shit, hope you can't read. Starting right at the bottom lower left, which is how it is on there. It actually shows you its progress. It's pretty cool. So I got the F done. Now it's making the passes around the R. I'm gonna let it go. So one thing I can see already is the text is really small, and it just, maybe if I changed the bit depth setting and made it one pass just for the text to be better, but it's taking off too much copper too close together. You can still read it basically, but I made even smaller fonts over here, which is all full of dust, but you're gonna see it's not gonna come out good. It's spelling out 5-volt O Y Y2 ground, and over here it actually is a little bigger. I made it small right here. It's way too small. So I just wanted to put a sticker on there, which is what I generally probably would have done anyway, but last minute I decided, hey, I'm just gonna see what it looks like adding text. Okay, I didn't record this process, but I just stuck a drill bit in there and drilled the smaller holes for my capacitors. Gosh, this thing doesn't want to focus on this thing. When I clean it, it'll look a lot better, but it actually landed on where they're supposed to go. So I think I'm gonna have to look back at my map, but it wants the next size. I think it'll tell me, right? So here's the order of the bit. So 0.7, I don't have that. I use my 0.8 millimeter. Now it wants 0.889, and then a 0.9. Both of those may as well be 0.9 millimeter. I don't have either one. I go from 0.8 to 1.0 with my kit. So at this point, I'll probably just send the next ones with the wobble and everything. It might be big enough. If not, then I'll just have to draw them out by hand later, make it fit. This is still a learning board here, although I think it's very well going to turn out to be a useful board, so I'm probably just going to use it. So learning this as we go, but it's pretty safe to say I'm just going to hit pause button. It should say resume because it is paused, and it's going to go hit the next batch of holes. Oh, look, it's going over to the where I probably needed a little closer to 1 millimeter, but I don't know. I said like 0.889 or something millimeters. I think it'll cram in there. But that's not the. This is gonna have a little bit of slop and wobble to it. This spindle, this is the basic one. Once I kind of get into this, I'll probably upgrade that to a better one. I guess people like to put an actual Dremel in there, one that probably gonna have the shank, you know, for these 3 millimeter, or what, about approximately 3 millimeter shafts. It's dirty right now, but when I looked at this, remember I said it was going to destroy where it says red or 5 volts and everything. It actually can still read it, 5 volts, OY, Y2, and ground. Different fonts, but this one here was just too fat and everything. It kind of was too close together. And those ones you could read over there: red, orange, yellow, Y2, common. So it didn't just take away some. No, it's just got dust on it. I blew it out in between there. So damn, it nailed those. Holy shit. So I know that I'm pretty sure that my component pins are going to fit in that 0.8. Actually, let's grab one of these freaking little things here. Yeah, this is 6 and it's got 5 holes. But it's dropping down in there from what it looks like. So I'm just going to let it keep using this 0.8 millimeter on everything now. Because if this fits in there, I know my component ICs, I'm pretty sure will fit in the other ones. So I just made this, and it's going to use a 2 millimeter wide bit that I'm going to put in, and it's going to cut the board out. Of course, this dimension and this dimension, I pretty much zeroed it right here, so it's probably not going to really cut much here. It's going to mostly cut here and here, but it's going to try to go all the way around nonetheless. Okay, before I send the board cutting program, let's go ahead and just blow those off so we can take a look at the board before I fuck it up, possibly. It's kind of hard to see on here, but it actually looks like all the holes went where they're supposed to be. I mean, those holes are spot on. Damn. The traces look like they're actually pretty good. And now I'm going to send it. It's going to cut, you know, this board out right here. Real close. So it's a 2. I'm still learning. Maybe that's too big of a bit. I don't know. I just didn't want to break the cheap bit, so I've set it for a 2 millimeter. If it starts freaking binding up or something, I'll just have to abort it. Because I did a 1 pass. It should next time I'll turn the feed rate down, but it isn't a losing step. You know, stepper motors haven't, you know, jumped or anything like that, you know, stalled, however you want to say it, where it loses its count, you know. But this should have been slower. I think I got it set for 80. The default setting like 200 or something. So that was to slow it down even more next time. But it's almost done now. I put the border line really tight in my CAD software just to make sure it was under 50 millimeters. Now it's going to go where the board's already, you know, cut. So it cut off some of the words. It's just starting to say the border was a little too tight to the board, so it kind of got it. But it didn't take off any components. It just lost right where it said what these pins were. I went ahead and etched the top layer, and I knew that I was etching the top layer. Traditionally on a single-sided board, you etch or cut the bottom layer and solder your components on the back side. I like to do them this way, like surface mount, kind of like, you know. Now, if I use this double-sided board here like this, it would if I soldered anything to the back side, it would short it out. But I originally was going to do double-sided. I probably am going to go back to double-sided now that I figured out how to use this machine. I'm probably going to order some bigger boards and just go back with my first layout, which was nice and spread out with everything on it. But also, remember I told you 0.8 millimeters. I had feeling that this needed a little larger. It's kind of funny because the CAD software actually mapped out what the size holes were. It actually pushes in there pretty tight. It still goes in when I push it down, but it's pretty tight. But I won't be able to solder it, you know, on the top side. So kind of would screw myself there, but you kind of get the idea. 5-pin connectors there and there, inputs, 24 volts going through diode resistor, then an optical isolator, which would be kind of like that, coming out the other side. Capacitor resistor to kind of filter out the, like I showed you guys in another video, filter out that rectified pulses from the 60 hertz, you know, 24 volts AC that was coming in. This is going to be 5 volts, so it's going to be a pulsed 5 volts, and then capacitor and a pull down resistor was going to level that out. and then it just go in the output. All this was an interface to convert when 24 volts is on, like reversion valve, it just puts 5 volts out. 5 volts comes from, you know, the power supply of the main microprocessor circuit. This right here, this division here, this is optical isolator. Everything on this side is from the 24 volt AC side. This side here is 5 volts from the microprocessor. So there's no actual, and it's, you know, anyone knows, if you don't know what optical isolator is, it's basically a diode inside here shining light across, and it's got a receiver, optical receiver built in it. That's like it's a photo transistor basically, and it'll bias that transistor with the light. There's no physical electrical connection, so a short over here can't blow up anything here, and vice versa. So when you hook inputs and outputs to your microprocessor, it's good to use them. Anyway, so I won't be using this board now that I think about it, but it was a good test just to see how the traces came out. Those settings, man, I nailed it. Just absolutely nailed it. So I have no doubt I'm gonna put my meter on here, and continuity probably I don't think there's anything bridged. It actually might be pretty close right there, but I could fix that if it is. I could make it a set the depth. What did I have at 0.1? Could make it 0.11 or something like that. Just one little measly change will thicken up these cuts. But yeah, it's pretty cool. It was looking pretty crappy at first. I was watching some videos and looking some stuff up, and this is a pretty frustrating thing for people to do. It looked like a lot of shit. Like I was like, man, am I gonna ever freaking get a freaking PCB board to cut out of this machine? And I just made this decision to even get into this like the beginning of the week. So then I just on a whim ordered that thing, ordered a couple bits, some cheap boards, and here it is Friday. By Friday, I've learned a new thing, which made me learn 3 new pieces of software. Just enter that. The first one is this is Easy EDA. Their purpose is you use this and then you basically create, you know, generate a Gerber. All right, I'm gonna go past this. Here's what I want to order or generate, and you order it, and they make the board, and here would be the board. There it is. Look how awesome that looks. If they were to etch it and mask it, it would look awesome like that. And so there's that software. So you save that Gerber files, and it breaks it down into so all these. So I have your drill points, your outline, which I just used that to load into the other one to make the toe worth to cut. I'm gonna have to not put the outline so close. Gerber bottom layer, the mask, which I'm not using, top layer, another silk screen I'm not using, and then the solder. So I'm just using the drill, the outline, and the bottom and upper. So I'm going to go back to dual-sided since these are dual-sided boards, or I can order single-sided and then use the actual file I pretty much made. But probably I'm going to try a double-sided next time. So there's that software. Go into this software. So once you get these all in here, now you can see. And I saw it here, and I said, I knew it was going to shave that, and said, fuck it, I'm just sending it because I needed to almost make this a little smaller for the size of that board, but I didn't. I already made this smaller and smaller to get all the parts in there by going back to this, and I kept moving it until I got it a little tighter. I could do a little better job and probably move this in. I got some room here. I could save a millimeter or two off right there. And then you get over here, and it's in here, and then you kind of use your tools. So top layer, you know, isolation tool, and then this is where you set all you make all the geometries, and then all the stuff I already did. So it's pretty cool. And after that, software is done, and you save. You have to save a CNC file for the top layer, CNC file for the bottom layer, CNC file for drilling the holes, a CNC file for cutting the board out, and then there's one more CNC file, which I actually got working before I could figure out how to do the traces. Was you put 4 peg holes somewhere. You preferably get a lot bigger board than this and put the peg holes outside of your design. But I figured out if I could use them inside and use them for my like this is what the idea was, because this would be where I'd bolt the board down, and I made way too big of a hole though, but I didn't know better. So you do that and use it for your pins. Oh, I know why I did that size, because I used for the pins to hold it down, I used something that I had 4 of, and that's these welder tips, 6.33 millimeter or whatever it was, set the hole and ground those. And that way, once you do that, this software, you could set it up so where you could flip the board back on those pegs, and it knows where it is for the geometry, and then you run the backside of the CNC, and it'll do the backside, and then you punch your holes, and it's all lined up. So I'm confident I'm going to get it done now. The only problem is I'm leaving town tomorrow morning, Saturday, and not going to be home till the Wednesday night next week, so I probably won't even work on this again till Thursday, almost a week from today. So this is going to sit for 6 days. Hopefully my brain remembers it, but I had to do this. Family's pissed that I kept coming out here and working on this shit for like 4 days in a row, but I would lose sleep. Just like I do when I'm doing coding, man. I don't have it done, I'll freaking dream about that shit. So anyway, so I'm at a stopping point now. I know I can make my boards. I know they're going to look awesome when I get done. I mean, aside from the screw-ups, which I just showed you, I know what to do better now.